So here we'll continue on with some more examples that demonstrate how we use our properties of exponents to those that are negative. And I'm on example 2, which begins on slide 15 on the PowerPoint posted in Canvas. So in example 2, we're going to take and apply these properties, but now to algebraic expressions. So not just to numerical values, but to expressions that have x's or y's in them, or possibly both. So part A is emphasizing what we do with exponents when we are multiplying like bases. We know that this is a situation where we add those exponents. So when I add -2 and -5, I get -7. But that is not considered a simplified answer because it has a negative exponent. So to get an exponent to be negative, we merely move it to the bottom from the top. That's like taking the reciprocal. So the x to the -7 is no longer on top, but becomes x to the +7 on bottom. And we know when everything cancels out on top, we're left with a 1. So we have 1 over x to the 7th. Part B of example 2 is one in which we have to apply the property that tells us to multiply exponents. So -2 times +4 is -8, but once again, we cannot have a negative exponent in our answer. So if it's on top, we move it to the bottom and that exponent becomes positive. Once again, we end up with a 1 on top over x to the 8th. In part C of example 2, we are dividing, but what we're dividing do not have the same bases, and therefore we cannot merely subtract their exponents. So we have to distribute this exponent outside to each of the exponents inside using multiplication, of course. And so 3 times -2 on top will give us a to the -6. -5 times -2 on bottom will give us b to the +10. Now we like the b because it has a positive exponent, but we don't like the a because it has a negative exponent. So we put it in its reciprocal form, which basically means move it down to the bottom from the top, and it will become a to the +6 power and go away from from where it was on top. So what we're left with in this case is 1 over a to the 6th, b to the 10th. This is actually part C for example 2. I just reversed C and D. But we can see that inside we have a quantity being multiplied, but the bases are different. So once again, we cannot merely add those exponents. We need to distribute the outside exponent to each exponent inside. So for the x, 2 times -4 is -8. And for the y, -3 times -4 is +12. The +12 is good. We leave the y alone. There needs to be nothing done with that y because it has a positive exponent. But the x needs to move down to the bottom to make its exponent positive. So it's going to become x to the +8 on bottom and no longer be on top. So in this case, we have y to the 12th over x to the 8th as our final answer. And finally, for example 2, we see that we are dividing two things that have the same base, so we can subtract their exponents. If we take the top exponent minus the bottom exponent, notice again, minus a negative is the same as plus a positive. So we end up with x to the -2 power. We don't like the negative exponent, so we move it down to the bottom from the top to make that exponent positive. So it will become x to the +2 on bottom and no longer be on top. Everything canceled on top, so we're left with just a 1 over x squared.